Welcome back. In this video, we're going to do an extended example of SLR parsing. To review, here's the parsing automaton for the grammar that we've been looking at in the last couple of videos. And this is just the deterministic version of the non-deterministic automaton we built last time. And I've just gone through and numbered all of the states. So let's take a look at what happens when we parse the input int times int. And just to review, we've appended $sign here to the end to indicate where the end of the input occurs. That's just an end of input marker. And because this is the beginning of the parse, we haven't seen any input yet, and so the vertical bar is all the way at the left-hand side of the input. So the machine begins in state 1, and there's nothing on the stack. The vertical bar is all the way to the left again, so the stack is empty, so it just terminates in state 1. And these are the possible items that are valid for the initial state of the parser. So among those items, we see that there are two that tell us that it's okay to shift an integer in this state. And of course, the first input is an integer. And so there are no reduce moves. All the other items in here also have their dots all the way at the left side of the item. So there's no possible reduce move in this state. The only thing we could possibly do is shift, and it's okay to shift an integer. So to summarize, on the initial configuration of the parser, the DFA halts in state 1. It never even gets out of state 1. It starts there and ends there without reading any input because the stack is empty. And the action that state tells us to do is to shift. So that leaves us in the following state. There's an int on the stack, and we have a times coming up in the input. So what happens in that situation? Well, again, the automaton is going to read the stack. So starting from the bottom of the stack, we're in the start state, and then we read an int. There's an int on the stack, and we wind up in this state. And what does this state tell us we can do? Well, it tells us one possibility is to reduce by t goes to int. But again, we will only do that if the following input is in the follow of t. And times, which is the next input item, is not in the follow of t. So times is not in the follow of t, and so reducing here is not a possibility. That leaves only the other item to consider, and here we see that this item says we can shift a time. So if times is the next thing in the input, which it is, it's okay to shift. So the DFA halts in state 3, and because there's a times in the input, the move is to shift. And that puts us into this configuration where we have int and times on the stack. Times is at the top of the stack, int is below it, and we have an int coming up in the input. So what happens now? Again, the DFA is going to read the entire stack. So beginning at the bottom of the stack, the first thing it sees is an int. It moves to that state, and then it sees a times, and so it moves to this state. And now, in this particular state, what are the possibilities? Well, we can see, first of all, that there are no reduce moves. There are no items with the dot all the way at the right end. So the only possibility is a shift. And we could shift if the upcoming input's a open paren, which it's not. More usefully, we could shift if the upcoming input is an int, which is exactly what we see. So the DFA terminates in state 11, and the move in that state is to shift. And that puts us into this state where we have int times int on the stack, and we are out of input. We are at the end of the input. So let's see what happens on the stack int times int. The automaton reads it, int times int, and it winds up back in state 3. And state 3 tells us that we can shift if the next input item is a times, which it is not, or we can reduce if whatever is next in the input is in the follow of t. And in fact, $ is in the follow of t, so the end of the input can come after a t on the stack. And that means it's fine to reduce by t goes to int. So once we do that, once we do the reduction, t goes to int, we wind up in the state int times t. That's our stack contents, and of course, we're still at the end of the input. So once again, the DFA is going to read the entire stack contents from the bottom to the top. First it reads the int at the bottom of the stack, then it sees the times, and then finally it reads the t at the top of the stack, and it winds up in a new state, state 4. And the interesting thing about this particular step is that the DFA took a different path through the state graph than it did the previous time, and that's because the stack contents changed. We didn't just add stuff to the stack, and so we didn't extend the previous path. We actually replaced some symbols or a symbol on the stack with a new symbol, in this case the non-terminal t, and that caused the DFA to take a different path. Now, what does this item in state 4 tell us to do? Well, it says that we can reduce by t goes to int times t if whatever follows in the input is in the follow of t. And once again, dollar is in the follow of t. And so we'll do that reduction. And now we're left with the stack contents just consisting of t. And of course, we're still at the end of the input. And let's see what happens now. So now, of course, the contents of the stack has changed even more radically. And so the DFA just goes off in a completely different direction. It reads t, winds up in this state. And this state says we can either shift a plus if there's a plus in the input. And again, there's no more input. Or we can reduce by e goes to t if dollar, if the end of the input is in the follow of e, which it is. And so the reduction move will be the one that we do. And now we have this stack contents consisting only of e. Let's see what happens in that situation. Now we make a transition to this state, state 2, and we only have one item, s prime goes to e dot, and so this is a reduced move, and again, dollar is in the follow of s prime, because that is the start symbol, and since that is the start symbol, we accept at this point. So once we get to that item as our reduce move, we know that the input has been successfully parsed.